Hi, so in this quartile mostly I've been working with a group on a university project for a subject related to visualization. In it we had to take a data set of 3, we had to choose, as our group as a whole, and we had to create a simple visualization tool based on that data set to solve a real world problem. Now, I did learn quite a bit about how visualization worked, and I think we've got a pretty good project in the end. It consisted of the final report, which I'm not going to show because it includes the real names of the people. There's the video, and there's of course the code base, which is like ridiculously long, and almost everyone, but for one person, worked on it. That one person apparently having had some trouble, but mostly being maybe somewhat unmotivated. That aside, though, I do think it absolutely works well. At least the code base, that is. When you execute it, you get like a web page with 3 interconnected graphs in which you can, let me just cut to the chase and show it to you. So as you can see here, this is what you get when you run the code. It's a web interface with a couple graphs and controls over there. The first thing that I wanted to point out is the scatter plot, which shows every incident as a dot, and if you hover over them you get a bit of information about that incident, such as the state, accident type, train type and date, and the hour of the day. The histogram shows the overall distribution of incidents over time and over a certain dependent variable, which can be selected via a set of controls. That's also true for the color feature of the parallel coordinates plot. So that could be equipment damage, casualties or injuries. The parallel coordinates plot is read like this. You go from left to right, and each feature is an independent variable and the color is a dependent variable. You can actually move the independent variables around if you wish, and you go from left to right every point where it meets another variable. You can actually brush or select in the PCP, and if you do, it affects the other plots as well. Of course, you can also use the scatter plot to brush in, like that, and it affects the other plots as well. So I'm just going to reload now, and when everything is updated, let's have a look at my feature, of course, because there's also a number of filters. This is the state drop down, that is the year slider for a time period in which the incident has had to be occurring, and finally there is a variable based filter which can select an independent or dependent variable, a condition smaller than, greater than, equals to, not equals to, and a value for which the condition has to apply. So for example, we're going to select train speed is smaller than 30, and then enable the VBF using the tick box, and then all of the plots adjust accordingly, as you can see here. So that is basically the system. It's quite simple, but it should allow railroad safety workers and inspectors to be able to detect correlations, extremes, distributions when it comes to incidents, and also to see how they can prevent these incidents. Anyway, I'm going to see you another time. Bye bye. I hope you've enjoyed this video. If you do, please give a thumbs up and share this video with all your friends, and perhaps consider subscribing to my channel. Thank you, and I'll see you next time.